While most people use cert-manager to secure ingresses, cert-manager can do way more. For example, one of the things it does is securing itself. But what if we could use that same technology to also secure other Kubernetes operators? Well, that's what our next speaker is talking about. Her friends call her the queer who yells at clouds, but you can just call her Danielle. Hi Danielle, welcome.
So I'm Danielle, and I'm going to be talking about something that I don't think many people might realize you could use cert-manager for. That's kind of annoying. And that's when you're sort of building like platforms on top of Kubernetes and want to extend Kubernetes with things like operators or admission controllers and, other similar things. So what is a webhook in Kubernetes? A Kubernetes webhook is something that lets you extend the core functionality of Kubernetes with various different things. So there's a few different types. The first would be a validating admission controller. This means that when you submit new resources to Kubernetes, the first thing that will happen, one of the last things that happens is they go through a set of validating webhooks. And what they can do is they can sort of like either accept or deny objects based on pretty much anything about the object. And in my demo later, I'll be showing you one of these in practice and like sort of how cert-manager helps you build those. Mutating admission webhooks, what they do when an object first enters Kubernetes is they will go through all of the mutating webhooks, and then they can describe a set of changes that they want to happen to the object. Say, for example, you wanted to make sure everything you submit to Kubernetes has like a name prefix or like default values for like requests or similar things. What these can do is they'll receive those objects, they can send those changes back, and then those changes happen before they're validated and accepted into Kubernetes. And the third type is CRD conversion webhooks, which are relatively new. But what they do is if you have CRDs with different versions, a conversion webhook will be used by Kubernetes to figure out how to return different API versions of the object. The problem with Kubernetes webhooks is they require TLS. And that can be really annoying when you have like a lot of different environments or a lot of different resources that you want to manage, because OpenSSL is really hard. So we'd rather use cert-manager for that, right? So that was a short introduction. And now I'm gonna like switch to terminal, which I hope is working because I don't know how Google Meet works. So what we have here is a simple little webhook that what it does is for every pod you try submitting to Kubernetes, it validates that it has CPU and memory limits. And if neither of those are true, then it will reject the so what happens here is if there are like, if there's any container that doesn't have a resource limit for CPU or memory, then we reject it. Otherwise, we continue and everything is okay. So we have to run that in a cluster. It just so happens that I should have one that works. Yes, my kubeconfig did not expire. So to do that, we have a couple of different ways of doing it. First, I'm going to show you how you would do this before cert-manager using some sadness with OpenSSL. So if we look inside here, we have a templated deployment that has our admission controller. It has a container with our webhook server that mounts in some secrets to serve over TLS. And then we register the validating webhook configuration, and we template in the CA bundle that the Kubernetes API server is going to use to validate your TLS certificates when trying to talk to your webhook. The way that gets populated and the certificates get generated is through a couple of different things. First, we have this bash script that will generate a self-signed CA and a certificate and private key that's going to be used by the demo server. This is kind of sad because as of Go 1.15, and therefore newer versions of Kubernetes, Go will no longer use the common name when validating certificates, which means here we have to set up stuff to support subject alternate names in the certificate, and set up the policies correctly, and then we can create a certificate for the internal service name. So you'd need to do this for basically every different webhook service you'd have in your cluster. Then what we have is a script that actually finishes the deployment. So it generates certificates, creates the namespace, creates a secret based on those keys, renders the deployment YAML, and applies it to Kubernetes. This is kind of annoying because it doesn't do anything around managing expired certificates. If you need to roll everything, you need to go and regenerate everything and redeploy, which is not so nice. But if we go and deploy that, I need OpenSSL. Oh, no, I don't want a nested thing. Did I break something? Oh no. That is unfun. But I have some certs here anyway, so if we... What is funny is this was working 5 minutes ago, but instead, if we set this to and don't do this either. It would help if I could Kubernetes. Okay. So this time everything gets created. So now we can go and see that we have a validating webhook configuration called demo webhook. And if we try to deploy an application that doesn't have resource limits, we'll see that this happens. But then if we get the events for the namespace, you'll see that we denied the request because the container is missing required CPU limits. And so we'll also see that it created no pods. But then if we go into here and give it some limits, and we go here, amazing. Is my internet just being wonky? Okay, here we go. It just took a little time for Scaleway to make me a load balancer. But here we go. You see the app is now running. So if we take that down, and we also take down the app. What we can take a look at now is how we'd replace that with cert-manager, which gets a lot of benefits, not just through not having to use OpenSSL, which I actively try and avoid in my life because it's stressful and frustrating, but because it makes our life better and handles all of the rotation and stuff that would usually get you paged at 2 a.m. Well, midnight, when your certificates expire. Because, you know, last time you regenerated the certificates was last time you had an incident at midnight. And then you like generate new ones for a year being like, that'll buy someone time to automate this. And they never do. Or there was that one time where a CTO generated certificates that lasted for 10, 24 days. And then our CA expired and all of our databases were inaccessible, which is fun times. So here we have basically the same deployment as we had before. We have some volume mounts that mounts the secret into the right place. We have a service. And then we also have a validating webhook configuration, but this is a little bit different to before. Rather than templating in a CA bundle, what we do is we annotate the configuration with cert-manager IO, inject CA from, and then you can specify either a secret or a certificate that you should automatically populate the CA bundle with. So the way we create that here is we have a self-signed issuer, because we're only using one certificate. You could also have like an internal CA that you use for like all of your webhooks, or, you know, various other ways of specifying your PKI. Then we have a certificate, and we annotate this to allow direct injection. What this means is cert-manager will allow that certificate to be used in places like this, and means that you can't like accidentally like pull in stuff that you don't want to. We set the DNS names that it should be valid for, and that's it. Like, that is all we need, and everything should just work, which is like much easier to understand than like my mess of OpenSSL bash. Partially because I'm not very good with OpenSSL, but also because OpenSSL is hard to use. So if we now try deploying this, everything gets registered, and then what we should be able to do is CM demo, get certificate. See here that we already have our webhook TLS certificate, and oh, exciting. We ran into a fun problem where we left our old validating webhook configuration in here, and that is not what we want. Validating webhook configuration. We get rid of this, and I'm gonna do this the easy way. of deleting and reapplying this. Do a little dance while we wait for Kubernetes. Okay. And then reapply. So now we see that everything was created successfully. We can see here that we successfully injected the CA bundle despite not specifying it ourselves. And then if we try deploying our application, this time it's gonna, oh, no, that's not what I wanted. If we try deploying our application again, this time it should work straight away because we didn't revert removing the limits. And then give Scaleway a little bit of time to create a load balancer. Come on, Scaleway. You can do it. I believe in you. Hey, here we go. And everything worked. And if like RCA expires, like certmanager is going to take care of dealing with that. Like we basically never have to touch this again, aside from like updating Kubernetes API versions, which I think is pretty nice. So what did we learn? We learned that admission webhooks can be really useful. Outside of that contrived example that used like everywhere, like certmanager uses them for injecting the CA. There are like webhooks that do things like integrating with open policy agents, so you can specify any sort of rules you want on your deployment, and a bunch of other stuff. And certmanager is really useful for managing like your internal PKI. Because managing that yourself is really hard, and Google Calendar is not a failure recovery strategy for your certificates. Like, I'm sorry, it's not. And it makes everything much easier to get started, which is always a benefit. So, thanks.
Thank you very much, Danielle. Our code is available on GitHub. I'll make sure she also shares it here on YouTube later. Thank you very much. We'll be back to you very soon with our next talk.